What if the very first ingredients for life didn't form on Earth at all, but were delivered here by comets already partially assembled in the icy darkness of deep space? In a stunning leap for astrochemistry, scientists have uncovered a molecular treasure trove around a young star named V883 Orion. Located 1,350 light-years away in the Orion constellation, this infant star is encircled by a swirling protoplanetary disk of gas, dust, and ice. The real surprise, within that disk, researchers detected 17 complex organic molecules, some never previously observed in such settings. Among them were ethylene glycol, the same compound used in antifreeze and glycolonitrile, closely related to essential components of DNA and amino acids. These aren't just exotic molecules, they're fundamental steps on the path toward life. And for the first time, they've been found not in distant clouds or ancient meteorites but in a newborn star system. This discovery challenges one of astronomy's long-standing assumptions, the reset hypothesis. According to that theory, the violent emergence of a star annihilates complex molecules formed earlier, wiping the chemical slate clean. But V883 Orion tells a different story. Instead of obliterating these organics, the transition from cold interstellar cloud to fiery young star seems to preserve and perhaps even amplify them. That didn't come without effort. The breakthrough was made possible by the Atacama Large Millimeter Array, ALMA, high in Chile's desert. This observatory's precise antennas can pick up the faint signals emitted by molecules at millimeter wavelengths. Here's where it gets fascinating. V883 Orion is still pulling in gas from its surrounding disk. These episodes of rapid growth unleash intense energy bursts that heat the disk. Imagine this. A sleek spacecraft lands back on Earth, carrying with it tiny pieces of rock and dust from the surface of Mars. Inside those rocks, frozen in time, could be the greatest discovery in human history, or the biggest threat. We've seen it all before in sci-fi. Aliens hiding in plain sight, taking over our bodies, our minds, our world. From the eerie replacement of humans in Invasion of the Body Snatchers to the grotesque shapeshifters that terrify us with stories of life from beyond. But let's be honest, nobody really believes an alien's going to crawl out of a pod and eat your face. But what if the real threat isn't something big and monstrous? What if it's microscopic, silent, invisible, and real? In the next decade, humanity is planning something extraordinary. A mission to Mars will not just explore, it will bring pieces of the red planet back home. NASA and ESA are already preparing for the Mars sample return mission. Enter Yohei Suzuki, an associate professor at the University of Tokyo, and his team. They've developed a cutting-edge method that could change everything. It's called optical photothermal infrared spectroscopy, or OPTIR for short, and it can detect signs of microbial life in rock samples without grinding them into dust. Let's break this down. Traditional methods like electron microscopy can reveal microscopic life, but they usually destroy the sample in the process. The organization overseeing planetary protection, COSPAR, has classified this as a Category 5 restricted Earth return mission. That's as serious as it gets. The goal to reduce the risk of accidentally releasing an alien microbe into Earth's environment to 1 in a million. So, while the movies like to show aliens crashing into Earth in a ball of fire, the real invasion, if it happens, might arrive in a test tube under tight quarantine, escorted by men in hazmat suits. An invisible star, a red dwarf, hides 124 light-years away from us, and orbiting this faint celestial body is a planet that could fundamentally alter our understanding of life in the universe. Its name is K218b. A team of astrophysicists from Cambridge working with data from NASA's ultra-sensitive James Webb Space Telescope has discovered chemical compounds in the planet's atmosphere that on Earth are produced exclusively by living organisms. The substances in question are dimethyl sulfide, DMS, and dimethyl disulfide, DMDS. On our planet, these gases are typically associated with marine plankton and certain bacteria. What they are doing in the skies of a distant exoplanet is still a mystery, but a mystery that might point toward extraterrestrial life. Professor Niku Madhusudan, the lead researcher on the project, calls this the most convincing evidence to date of potential life beyond Earth. But scientists, including Madhusudan's own team, urge caution. The current data, while impressive, still fall short of the rigorous standards required for a formal scientific discovery. To claim definitive proof, they need a statistical confidence level of 99.9999%. At present, the result stands at 3 sigma or 99.7%. A significant improvement from previous estimates of 68%, but still not enough. Other researchers and independent experts echo the cautious tone. Aliens might already be out there, and the next generation of space telescopes could actually see them, not in flying saucers or shadowy silhouettes against the stars, but in the faint, twisted glow of polarized light bouncing off an alien ocean. The key to unlocking this interstellar mystery, a telescope so advanced, so precise, it could detect life not by accident but by design. It's called the Habitable Worlds Observatory, and it's humanity's most serious attempt yet to answer the oldest question: are we alone? Its mission unfolds in 4 stages, each one peeling back a layer of the unknown. First, identify potentially habitable exoplanets. You're looking for tiny dim specks of light next to the blinding blaze of their parent stars. But HWO is equipped with a built-in coronagraph. Second, look for the hallmarks of life, the most immediate clue, color, specifically biopigments, substances like chlorophyll that reflect and absorb light in particular ways. These signatures show up in polarized light, and then comes the final breathtaking step, searching for chirality. Life on Earth exclusively uses molecules that are handed either left-handed or right-handed, but never both. This asymmetry, called homochirality, is a universal trait of biological systems, and astonishingly, it leaves a telltale signature in circularly polarized light, a kind of light that spirals as it travels. Circular polarization is rare in nature, and its biological origins make it stand out like a flare in the darkness. Brace yourself. We might be living in a ginormous black hole. The James Webb Space Telescope has been sending back some pretty crazy stuff. It has looked at a bunch of really faraway galaxies, those super old ones from the early universe. And guess what? Most of them are spinning in the same direction, to be precise, around 2/3 spin clockwise and only 1/3 spin the other way. But if the universe was totally random, you'd expect it to be 50-50ths, half going one way, half the other. And that's not what's happening, and there's also this wild theory that everything we see might actually be inside a giant black hole. This idea was first brought up when some smart folks noticed that the edge of a black hole called the event horizon might actually line up with the edge of our observable universe. If that's true, then every black hole in our universe could actually be hiding a whole other universe inside it, a so-called baby universe. We just can't see or reach them because of that same event horizon. It's like a one-way door. When a massive star dies, its core collapses and forms a black hole. Normally, we think everything gets crushed into a super tiny point called a singularity. But there's another theory. When things get that dense, something called torsion kicks in, and when that twisting force gets strong enough, it stops the collapse and causes a massive bounce. A similar bounce might have started our universe. So, instead of a big bang out of nowhere, we might have had a big bounce from inside a black hole. Mars has long been a source of mystery and fascination, with numerous anomalies discovered on its surface that challenge conventional explanations. Among the most intriguing is a square-shaped formation captured by the Mars Global Surveyor's orbiter camera. This unusual structure, visible in an image available through Arizona State University's Mars Image Explorer, has sparked intense debate among researchers and enthusiasts alike. Many believe that this geometric formation warrants further investigation. Unlike the chaotic natural formations typically seen on Mars, this structure exhibits a level of symmetry and geometric precision rarely found in nature. Most natural geological processes, such as erosion and volcanic activity, tend to create irregular, unpredictable formations. Some skeptics argue that its unique shape indicates an artificial or intelligently designed origin, pointing to the possibility that Mars may have once harbored an advanced civilization or been visited by extraterrestrial beings in the distant past. NASA and other space agencies have largely remained silent on the implications of these formations, often dismissing them as natural rock formations or imaging artifacts. However, this stance has not deterred independent researchers from continuing to investigate. With the increasing availability of high-resolution images from Mars rovers and orbiters, more anomalies are being identified, adding to the growing body of evidence suggesting Mars may not be the barren, lifeless world it is often portrayed to be. Picture this: we finally make contact with aliens. Exciting, isn't it? But then comes the big question: how do you even start a conversation with beings who might be as different from us as apples are from algebra? Enter Olaf Wachowski with an idea that's, well, pretty out there. He thinks the best way to say hello to extraterrestrials is to threaten them. Here's his reasoning. No matter what kind of alien life form we're dealing with, there's one universal trait all life shares: the will to survive. It's the basic definition of life itself. His idea is to make them feel like their survival is under threat because, as he puts it, they'll understand that. Essentially, it's like tapping on a fish tank to see if the fish are awake. Except the fish tank is the entire cosmos, and we're hoping something intelligent is listening out there in the vast darkness between the stars. So next time you gaze up at Orion's belt, imagine what's unfolding inside those stellar nurseries. Molecules coalescing, chemistry evolving, the seeds of life already in motion. Because life doesn't start on a planet, it starts in a cloud sculpted by radiation and time, etched into ice and carried across the galaxy, written in a molecular script as old as the stars themselves.